You Yes, yes, yes. Can I have a Gucci in the chat box? Gucci, 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 Gucci. Yes, 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 yes. Can everybody write Gucci in the chat box? Let's start, everybody. So we're gonna further continue off with our chemical energetics questions. And this question says, this question is about energy changes that takes place during a chemical reaction. Which energy changes takes place during a chemical reaction, which we need to know for our chemical energetics? Which energy changes? We know that energy is either taken in from the surroundings or it's given out to the surroundings overall, right? Is given out, and if it's taken in, we call it what? If it's taken in, we call it what? We call it endothermic or exothermic. If it's taken in from the surroundings, what do we call it? If it's taken in from the surroundings, we call it endothermic. If it's given out to the surroundings, we call it exothermics, right? And now it says nitrogen reacts with oxygen to make nitrogen monoxide. The reaction is endothermic, which means that the overall enthalpy change is going to be positive or negative. For endothermic reaction, the enthalpy change is obviously going to be positive, or it is draw on the axis provided the reaction pathway provided in figure 6.1, the reaction pathway diagram for this reaction. The label includes the axes. So what do we have on the axis? We have energy, and you could also label it, right? You have energy in kilojoules, and here on the x-axis you have reaction progress or reaction pathway. Since he has used the word pathway, I'll use the word pathway right here, or you could also use the word reaction progress, right? Reaction chalra. Now if it's an endothermic reaction, that means obviously in every chemical reaction, first of all the bonds must be broken, and then which is endothermic, and then the bonds must form, which is exothermic. But if it's an endothermic reaction, we know that bond breaking is endo and bond formation is exo. But if it's endothermic, we know that energy taken in during bond breaking is going to be less than the energy given out, is going to be more than the energy given out during bond formation, right? So taken in is going to be more than given out, right? And we know from the reactants, here you have reactants, right? So you could write reactants here because he's used the word reactants, and you could write the word product here because he's used the word product, although you could have also written this beauty as your reactants and this beauty as your product. But what I'd suggest is, if he has specified to include this particular word, if he has specified to include this particular word, you should include reactants and products, right? And we know that the EA is from the reactants to the top, that's my EA, and the enthalpy change is from the reactants to the products, which obviously going to be positive. Why is it positive, everybody? Why is the enthalpy change positive? Because you realize that energy taken in is this much and energy given out is this much, right? You realize that this is the activation, and that's the the EA, the activation energy needed for these reactant particles to undergo successful collision. And you know that this is the transition state, it's the activated complex. After this state, bond formation starts to take place, and that's why energy is given out. And till this point, till this maximum point, energy is taken in during bond breaking. Done. So you don't need to include these green lines. Muft ke marks, muft ke marks, everybody, muft ke marks, muft. 5 marks for literally nothing. 5 marks, 1 mark for this, 1 mark for this, 2 mark, 3 mark, 4 mark, and 5 mark. Done. Moving forward. Okay. Hydrogen reacts with bromine to make hydrogen bromide. Calculate the enthalpy change of this reaction. How do you calculate enthalpy change? You know that in order for reactants to react together, all the bonds must be broken first, and then bonds must form, right? So first the hydrogen bond needs to be broken, and you have 1 mole of this beauty right here, and you need to break the bromine molecule bond, right? So you need to break this bond and you need to break this bond. So bonds broken, what's the energy taken in during bond breaking? 1 multiplied by HH bond is 436. So 1 multiplied by 436 plus 1 multiplied by BR bond is 193. 1 multiplied by 193. What do we get, everybody? Please, please, please give me the correct answers. Please give me the correct answers. What do you get? 629. Thank you, Musa. So 629 kilojoules. That's the energy taken in during bond breaking. Should I add a positive sign or a negative sign to it? Remember, we're talking about energy. You've studied this in your physics. Energy is a scalar quantity. You do not add positive or negative signs to energy. Sir, but you used to add negative signs and positive signs. I used to add them when I was calculating enthalpy change. So remember, enthalpy change is the transfer of thermal energy during a chemical reaction. And in order to tell the examiner that, the transfer is from the overall transfer is from the surroundings. The overall transfer is that energy is taken in. That's why you add a positive sign, just to tell the examiner that overall energy is taken in. And you add a negative sign to tell the examiner that overall the transfer of chemical energy is outside the system, is going to the surroundings, is given out, right? But remember, when I am calculating the energy taken in during bond breaking or the energy given out during bond formation, it's just going to be a scalar quantity. Done? So bond breaking में ये energy है, और जनाबे वाला bond formation में कितनी energy release हुई होगी? Check this out. You have a H and Br bond forming. So you have HBr bond forming. And how many moles of these do you have? You have 2 moles of HBr bonds forming, right? So if one is 366, for 2 moles, you times it by 2. What do you get? Or you could simply say you have HBr here and 2 moles means that you have 2 HBrs, right? So this bond forms and this bond forms. What do you get? 732. Thank you very much. So 7, do I add a positive or negative sign? No, I don't. Do I add a positive negative sign? No, I don't. Why? Because we're talking about energy. Yes, but if I now talk about enthalpy change, it is the energy taken in during bond breaking, less energy given out during bond formation. Because you know that energy taken in during bond breaking is represented with a positive sign and given out is represented with a negative sign, right? So what do we get? Only for the purpose of calculating enthalpy change. So 629 minus 732. What do we get, everybody? What do we get? Come on. 103 kilojoule per mole. Khatam. It's minus or plus? Minus. Thank you. Obviously it's minus. Thank you for correcting. Yaar, it's not 109, yaar, 103 hai. Come on यार, कैलकुलेटर तो इस्तेमाल कर लें. अच्छा, अब देखिए you need to be very very exam specific. कितने आसान सवाल है इसमें, क्या है हलवा है. You need to be very exam specific because you need to understand that if he's written the reactants for you, should you write the word products? Should you write the word products or should you write C2H4Br2? Anybody? Should you write the word products or should you write C2H4Br2, the name of the product? Obviously, yes, Harim, because he has already given you the name. So it's better to write the name instead of the word products. Done? So it's saying ethene is an alkene which reacts with blah, blah, blah. The reaction is exothermic. Boom. If it's exothermic, the energy taken in during bond breaking is less than the energy given out during bond formation, right? Taken in is this much and given out is more, right? And you could also see it by drawing a highlighter, right? So taken in is less and given out is more. Beauty, 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 beauty. Okay. So from the reactants to the top, that's the EA. Always from the reactants to the top, and from the reactants to the products, that's the enthalpy change, which is obviously going to be negative. How do I know it's negative? Because taken in is this much and given out is more than taken in. So it's obviously negative. Done. And do we write the word products or the name of the products or the symbol of the products? We write the symbol of the products, which is C2H4Br. Boom. 4 marks muft ke, 3 marks muft ke. It says complete the diagram to show the position of the products. I've shown it. An arrow to show the activation energy labeled as A. So now I would only get 2 marks, not 3 marks, because he said to label it with A, not to label it as EA. So this will give me the mark, right? Don't label it as EA if he has specified the word for you. If he said label it as A, then you have to label it as A instead of EA. And it says an arrow to show the energy change for the reaction. We know that the overall energy change is called the enthalpy change, and that's the arrow for it. Done. Done, everybody. Khatam, आगे जाऊं? Use the bond energies in the table to calculate the energy change in this reaction. Use the following step. Okay, again, what's going to happen. And here I will also teach you a shortcut. So you are not going to apply this shortcut you'll only apply this shortcut in the MCQs paper. You cannot apply it in the theory paper because it's not the real concept. It's just a shortcut. But first, let's look at the concept. So we know that first of all, what happens when a chemical reaction takes place? First of all these bonds must be broken. So 1, 2, 3, 4, because he's asking us to calculate enthalpy change, right? So I can do it on my own. Instead of him guiding me, I can do it on my own. What do we need to do? Break this bond, break this bond, break this bond, break this bond. How many bonds of CH are breaking? 4 CH bonds are breaking. Done, sir. 4 CH bonds are breaking. Okay. And 1 C double bonded to C bond is going to break. Isn't that true? 1 C double bonded to C bond is going to break. Done. And 1 Br bond is going to break. Br bonded to Br. Khatam. That's all the bonds that are going to break. And what are all the bonds that are going to form? So 1 CH bond, 2 CH bond, 3 CH bond, 4 CH bond. So you know that bond breaking is this much. And then you just need to plug in the values. 4 CH bonds plus one CC bond plus one CBr, one CBr. All the bonds. Have I shown all the bonds? So two CBr bonds. Khadam, just plug in the values now. So what's the energy? Calculate the energy needed to break the bonds. I'll paste this here. What is the energy needed to take in to break these bonds? Come on, just plug in the values for me. 4 CH bonds. So that's 410. You just need to break all the bonds. Done. Plus 1 times C double bonded to C, 610. Plus 1 times BR, that's 190. What do we get, everybody? What do we get? Please give me the correct answers. We can't afford to get wrong answers. So 2440, I'm trusting you guys with it. Thank you for being active. So 2440 kilojoules. It's not kilojoule per mole because it's energy. Enthalpy change is kilojoule per mole. Please don't write kilojoule per mole. Although the unit is already written for you guys. Okay, calculate the energy released when these bond forms. Do I need to add a positive or negative sign to it? No, I don't. No, I don't, because energy is a scalar quantity. When we talk about enthalpy change, we only represent it with a positive or negative sign, just to tell the examiner whether overall energy is taken in or given out. Okay, today I'm in motion. Yes, I know. 4 CH bonds. What's CH bond? 410 plus 1 CC bond. CC bond is 350. Kitna aasan hai? You guys think that this is difficult? What is difficult about this? Tell me. CBr bond, 290. What's difficult about this? What do we get, everybody? Come on. 2570. I'm trusting you with it. 2570. 2570. So what's the enthalpy change? Enthalpy change is energy taken in during bond breaking minus energy given out during bond formation. Bond breaking kitna hai? 2440 minus bond formation 2570. What do you get? The answer is obviously negative. What do you get? Negative 130. Thank you. Negative 130 kilojoule per mole. Negative 130 kilojoule per mole. Now, look at the shortcut. Look at the shortcut now. See, what you could do is you could also do a shortcut here, and I'll teach you the shortcut right now. Look at this. The shortcut is to realize, the shortcut is to realize what is changing from left to right. So that's a BR here. That's a BR here. That's a BR here, and these are the H's. Now, check it out. What's changing from left to right? This CH bond and this CH bond is the same. This CH bond and this CH bond is the same. This CH bond and this CH bond is the same. This CH bond and this CH bond is the same. What has effectively changed? What is the net change between the two? Because you realize you add these four and you subtract these four, both cancel out, and you're going to get 0 at the end, right? So this will not have effect. What's the change? The change is effectively the C double bonded to C right here. That's one change between left and right, and this is the change, right? So the new bonds that are not similar to the reactant side is this bond here, and this bond here. Right? So you could just take the net effect. You could take the net effect. What is the net effect? You could just say, hey, the only change between reactants and products is that here you had a double bond, now you have a single bond. Here you had Br bonded to Br, and now it's going to break down and it's going to be C bonded to Br and C bonded to Br. This CH4, this C bonded to 2 hydrogens and this C bonded to 2 hydrogen is both same on the left and right. So let's just take the change. Let's just take the change. What is the change? 1 C double bonded to C, so that's going to be 1 times 610 plus Br bond, that's 190. What do we get? What do we get here, boys? Boys and girls, what do we get here? We get 800. Remember, it's not the right answer. It's a shortcut to calculate enthalpy change, because in enthalpy change, the net effect would remain the same. Shortcut. Just write it here. Shortcut. Only to be used for MCQs. Actually, you're gonna notice if you do papers before, like, in 2015, in 2016, they would have done this in the marking team. You will not do it. You will use the proper concept, which is, first of all bonds are broken, then bonds form. First of all bonds are broken, then they are formed. So you're not going to do the shortcut, even though in 2015-16, the marking scheme, Cambridge was stupid back then. So the marking scheme might include a shortcut. You will not use this shortcut. Done. Okay, this is only for MCQ. So that's the energy taken in during bond breaking. The net energy, remember, this is net change. We're talking about the net change. And what is the net change in products? You have 2 CBr bonds and you have 1 CC bond. Ain't that true? What do we get? 2 CBr bonds. What do you get? 2 times 290 plus 1 times CC bond, which is 350. What do we get, peeps? What do we get? What do we get here? That's 800. Remember, 800 is not the energy taken in during bond breaking. This is the energy. This is just a shortcut. That's 930. So can you guys, that's the bond formation, right? That's the energy taken, given out during bond formation, the net energy. So what's the change? If I want to calculate the enthalpy change, that's going to be energy taken in during bond breaking, the net energy minus energy given out during bond formation. What does that give me? Minus 130. And look at this, it'll tally with what we've done. So this is a shortcut that you could use in the exam. That's it. In the MCQs, only in the MCQs. Let me also write it here for you because some of you dumbos might still end up doing this. So I'll write it here, only to be used in MCQs. Done? आगे बढ़े कितना आसान है what's this A come on what's the A from the reactants to the top that's the activation energy and please read the question I've done these questions a gazillion times so I'm writing it directly but read the question like in the previous question he said represent the activation energy as A so if you had written EA he would have cut the mark for it because you weren't following instructions so that's the EA and from the reactants to the products that's the enthalpy change, right? And is it an endothermic reaction or an exothermic reaction? Energy taken in during bond breaking is less than the energy given out during bond formation, right? Taken in is this much, given out is this beauty, right? So it's exothermic. Boom, 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 boom. Everybody is on top of their game. Name the energy change labeled A. What's the energy change labeled A? That's called the activation energy. Sir, can we use the symbol EA? It's better not to use it because he's saying name it. He's not saying write the symbol for it. He's saying name it, right? So you don't want to risk your mark. Although sometimes Cambridge does give marks for it, but you don't want to risk it. Do you want to risk it? If you do want to risk it, that's up to you. But if you don't want to risk it, that's also up to you, right? Name the energy change label B. What's the energy change label B? What's the energy change label B? What's B? What's B? It's the enthalpy change. I'm going to write it's the enthalpy change. And enthalpy change is also called energy change, right? So you could also call it energy change, but it's better to write enthalpy change, please. Better to write. The marking scheme sometimes writes this, but this is the better word because you don't get the updated marking scheme. There are a lot of correct options in the Cambridge guidance marking scheme, which they used to check your paper. So don't worry, if something's not in the marking scheme, that doesn't mean it's wrong. You can always concur with me, right? Okay. State how the energy profile diagram shows that it's an exothermic reaction. Harim wrong. गलत. Harim का तो answer गलत. मैंने आपको बताया था. Remember when I was teaching this chapter, I said that the examiner will give you a graph and he will say, how does this graph show? Remember, I've taught you guys this. Use your brain. Look over your notes. Yes, Musa is right. Musa is right. Yes, yes, yes. Noor is also right. So you could either say from the graph, you can't say that energy of the bond breaking energy is energy taken in during bond breaking is less than the energy given out during bond formation. No, the basic crux of this is that if reactants have more energy than products, it's an exothermic reaction because you realize that overall reactants are losing that energy, or you could say products have less energy than reactants. This is not what you wrote, Harim. You said, oh, Harim is also right. Okay, sorry. I thought you wrote bond breaking and bond formation. Sorry. So Harim is also right. My bad. So energy, see, it says, how does the profile diagram, how does the graph show? Remember, I've taught you this. Have I not? Have I not taught you this? Have I taught you this? Yes. Yes, that's why I'm the GOAT, OG. So energy of reactants, or you could say energy of products, is lower than the energy of reactants. Khatam. Or you could say energy of reactants is more than the sir, please don't do this near my mom will beat me up. Okay, chill. Or you could also have written it vice versa. Energy of reactants is more than the energy of products. You could have written both ways. Done? Okay, again, it says calculate the energy. Can you guys do this on your own? Can we do this on our own? See, you could use a shortcut, but not here, only in the MCQs. For now, all the bonds must be broken. 1, 2, 3, 4, 5, 6. 6 CH bonds are gonna break. And then one CC bond is gonna break. So one CC bond breaks and one CL bond breaks. Done? It's literally muft ke marks. This bond forms, this bond forms, this bond forms, this bond forms, this bond forms. So how many CH bond forms? 5 CH bond forms. Done, sir. 1 CC bond forms. And 1 CCl bond forms. So you just have to make sure that you take into consideration all the bonds. And here you have 1 HCl bond form. What if here you had 2? Then you'd say 1 HCl bond forms, but you have 2 moles of this. So you would send 1 HCl, 1 times HCl, but you have 2 of these, right? But here you only have 1, right? So done. That's 1 HCl bond forming. Because bond energy is in kilojoule per mole, right? So it's only for 1 mole. So this energy that you have 430, that's for 1 mole. If you had 2 of these, then you would have to multiply by 2. Sir, can we do all the circle and make mess in the exam paper? Yes, you can. If it makes things easy for you, you can. It doesn't matter as long as you don't make a mess here. Yeah. Okay, so let's do this beauty. Let's do this beauty. So let's copy this and paste it. Boom shakalaka. Here we go. That's the energy taken in during bond breaking. And let's copy this beauty right here. This is beauty. Let's paste it. And let's just add this beauty here. Done. Just plug in the values for crying out loud now. So 6 times CH bond. CH bond is what? CH, that's 410. So 6 times 410 plus 1 times CC bond. That's 350. And plus 1 times CL bond. That's what? 240. Can you guys tell me the answer to this, please? Can you guys tell me the answer? It's 3050. Sure, 100%. Can everybody calculate it with their calculators? 3050. We can't afford wrong answers because this is a video solution. So it's going to be used for the later years to come, for all the years to come. Right? 5 times CH bond. CH bond, because I'll probably be the only teacher who will be solving every single question of 100 papers on his own for you guys, so that you guys don't have to use your brain that much. Right? And you guys always have guidance as to how to go about the questions. So it's a CC bond. CC bond is what? CC bond energy, CC, that's 350. So 1 times 350 plus 1 times CCl bond, that's 340, plus 1 times HCl bond, that's 430. What do we get, guys? Can somebody use a calculator and tell me what do we get? 3170. Anas, I'm trusting you, man. 317. Should I add positive negative sign here? Positive negative sign? No, it's energy. It's energy. It's energy. Okay. Determine the enthalpy change. Energy taken, energy is a scalar quantity. No? Bond breaking. Why are you then writing enthalpy change with a positive negative? Just to show whether the transfer of energy is outside the system or inside the system overall. So overall, bond energy taken in during bond breaking is 3050 and energy given out during bond formation is 3170. So what do we get? Minus 120 kilojoule per mole. There's one question that is very beautiful. I hope it comes up before the next part. So I hope it comes up because it hasn't been tested. I can't see it being tested recently. It hasn't been tested in quite some time. I see. Yes, it's not been tested. So probably it might be tested in your paper. I want that question to come up. I don't think it'll come up in this practice session. I think it'll come up in the next practice session. Okay. So chloroethene can be manufactured from 1 to blah 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 blah. The equation shows whatever bullshit. Sorry, whatever bakwas is written here. We know how to calculate the energy, the enthalpy change. So it says use the calculate the enthalpy change. This bond is gonna break. 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 So how many CH bonds are breaking? 4 CH bonds. This bond breaks. This bond breaks. 2 CCl bonds break. And this beauty breaks right here. 1 CC bond is gonna break. Done, sir. And then, what are the bonds forming? How many CH bonds are forming? Uno, dos, tres. I do these circles to not miss anything. You could also do this for yourself. So 3 CH bonds form, 1 CCl bonds form. The only mistake you guys could do is forget about taking a bond. Remember, take into account all the bonds that will break and all the bonds that will form. So 1 C double bonded to C bond is gonna break, yeah? CC bond. Oh, my bad. CC bond. Khadam? And sorry, form. and one HCl bond forms. So let's see. आसान है मुश्किल है. And now I'll just copy it. And these are the energy. This is the energy taken in during bond breaking. And that's the energy given out during bond formation. कितना आसान है. Literally, this is muft ke marks. If you guys mess this up, it's on you. It's on you. Okay, so you can't mess this up. It's pretty simple, right? So 4 times, it's just plugging in values. CH bonds, CH, just have to search for it. 410 plus 2 times CCl, 340 plus 1 times, why am I have written a plus here? That's 1 times, yeah. Plus 1 time CC bond, that's 350. Asan hai, mushkil hai? Can you guys write in the chat box? What do we get? What do we get? 2670, everybody. Yes, is everybody ending up with 2670? So 2670. Should I add a positive or negative sign? No, it's energy. Energy is in kilojoules. Okay, CH bond, that's 410, 3 times 410. Asan hai, mushkil hai. 1 times CCl bond forms, that's 340. Plus 1 times CC bond. CC bond is what? CC bond. CC double bond? CC double bond is 610. Boom, boom. Plus 1 times HCl 430. 1 times 430. Khatam, what do we get, please? 2610. Thank you. So 2610. Can somebody confirm this, please, too? So enthalpy change. Energy taken in during bond breaking is 2670. And energy given out during bond formation is 2610. What do you get? Plus 60. So plus 60 kilojoule per mole. आसान है मुश्किल है? Easy lemon squeezy. Deduce whether the energy change for this reaction is endo or exo. Come on, you guys can do this on your own. How do you know? How do you know? How do you know it's an endo or an exo reaction? We know that it's an endothermic reaction because the enthalpy change has a positive sign. Done. So it's an endothermic, and it says give reason. The endothermic reaction because the enthalpy change, or you could say the energy change, your choice. The enthalpy or the energy change has a positive sign. Khatam. Khatam. Boom shakalaka, shakalaka taka. Khatam. Asha. This is also a relatively easy question. I want that one question to come up. If they make 60% of P4 with these questions, to maza aa jayega. Beta sare organic chemistry, they're going to give you your theory paper will consist of almost around 20 marks from organic chemistry. Full sucha. Or wo 20 marks, 100% I am guaranteeing. If you don't miss organic chemistry class, I am guaranteeing myself that you will score 20 out of 20 or whatever the threshold is. You'll score full marks in organic chemistry and you'll also score full marks in moles and stoichiometry. So if you've taken the lectures of moles and done all the practice that I've done in class, that's all you need. Okay, so now look at this question is a little different. This question is, he's saying the energy change for the overall reaction is minus 180 kilojoule per mole. What has he given you? What has he given you? He's given you the enthalpy change, the energy change. So something might be missing. If he's giving you the enthalpy change, some bond energy might be missing, and he is going to ask you to calculate it. And that's what he's doing. He's saying use the bond energies in the table to calculate the bond energy of CCl bond. So you're not given the bond energy of CCl bond in kilojoule per mole. You're not given that bond energy, right? And you know that enthalpy change is, first of all, let's calculate bonds broken, right? Let's do the same thing. So this bond is going to break, this bond is going to break, this bond is going to break, this bond is going to break. How many bonds are going to break? I'm not going to follow the steps. I want you guys to think on your own and then you could follow the steps for ease. But think on your own. How many bonds of these are going to break? So 4 CH bonds are going to break. 4 CH bonds. Sir, 1 C double bonded to C is going to break right here. 1 C double bonded to C. So plus, that's the energy taken in during bond breaking. This done. And 1 CCl bond plus 1, sorry, CL bond. Khatam. That's the energy taken in during bond breaking. Yes or no? What's the energy given out during bond formation? 1, 2, 3, 4. 4 CH bonds. So 4 CH bonds, done sir. Plus 1 CC bond, 1 CC bond plus one CCl bond and one CCl bond. So two CCl bonds. Now look at this beauty. Look at the game here. He is just gonna use simple mathematics to confuse you, and you're gonna get confused. You're not gonna get confused if you're my student, obviously, because you know he's just playing around with numbers at this point. This examiner did not have anything else to do, so he started to play around with numbers, right? So look at this. He's saying calculate the energy needed to break the bonds. You could obviously do it because you have all the values for it. So 4 times 410 plus 1 times C double bonded to C 610 plus 1 times Cl bonded to Cl 240. What do we get? What do we get, everybody? 2490. Thank you, thank you, thank you. 2490. That's the energy taken into your bond breaking. Now my question is CCH bond 4 times. Oh, let's not use this green, stupid bakwas green color. Okay, let's use this color. 4 times CH bond. That's 410. And 1 times CC bond. CC bond is what? 350. Plus 2 times CCl bond. Do you have the value for CCl bond? Do you have the value for CCl bond? No, you don't. And I'm going to call this CCl bond X. I don't have the value. And that's what he's saying. He's saying use your answer in step 1 and the energy change of this reaction to determine the energy released when these bonds form. The energy released when these bonds form. What do I have to do? What do I have to do? What's the energy released when these bonds form? Come on. What is step 1? Use your answer to step 1. Use this beauty and the energy change to determine the energy released when these bonds form. Now look at this. It's 2 times X, but you don't know what X is, right? So what is the energy released when these bonds form? What is the energy released when these bonds form? These bonds right here. I don't know the 2X meaning. I don't have the value of 2X. I don't have the value of 2X. I don't have the value of 2X. हाँ जी क्या रहा है क्या रही नहीं so just tell me this bit, what do we have? What do we get? 1990. Thank you. So that's 1990, right? So that's 1990. That's the energy released when these bonds form. But wait, hold up a second. That's the energy released when these bonds form. But it says use your answer in step 2 and the bond energy values to determine the energy of CCl bond. Now let's look at this. Let's determine the energy of CCl bond. You know that enthalpy change is the energy, Enthalpy change is the energy taken in during bond breaking less the energy given out during bond formation. What's the energy taken in during bond breaking? 2490. What's the energy given out during bond formation? That's 1990 plus 2x. That's the energy given out during bond formation. And the sum of these should be equal to what? What should this be equal to? Anji, what should this be equal to? The enthalpy change. What's the enthalpy change, everybody? He's given it to you. Minus 180. That's minus 180. Calculate it. Calculate for x, please. The enthalpy change is not 995, yaar. Kya ho gaya? What do you get? 2490 minus 99. Yeah, maths ki equation ban gayi, yaar. 1 minus 180. He's given you the enthalpy change and he wants you to calculate it. Chalo, calculate it for me. Calculate the CCl bond, CCl bond, whatever. Anji. How minus 180? It's given in the question. The enthalpy change for this reaction is minus 180. Anji. 340. So x is equal to, is this the value of x? X is equal to 340 kilojoule per mole. अच्छा 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 वेट सही कह रहे कुछ बच्चे सही कह रहे कुछ बच्चे कह रहे हैं कि सर दे वांटेड यू टू कैलकुलेट दिस एज इट इज राइट सो यू कुड डू दैट नो दिस इज नॉट 1990 it's saying use your step 1 and the energy from the reaction to determine the energy released when these bonds form. Okay, he's talking about the CCl bond, right? He's talking about the CCl bond. So basically it's what? 2490, that's the energy taken in during bond breaking, minus 1990, that's the energy given out during bond formation, and minus 2x, that's the energy given out during bond formation, right? So he's effectively asking you to give the answer in the form of 2x, right? So that's 2490 minus 1990. What do you get here? 2490 minus 1990. 500 आ रहा है? 2490. We're making a mistake. We're making a mistake somewhere. I need to find the bond energy of. क्या चल रहा है? क्या चल रहा है? We're making a mistake. Use your answer to step 1 and the energy change for the reaction to determine the energy released when these bonds form. What sir, bonds form, shouldn't we add 180? Oh, yes. Thank you. Musa's right. Thank you. So basically, oh my God. So pathetic. See, the enthalpy change, my bad. Look. That's not what the question is saying. The question is saying, use your answer in step 1 and the energy change to calculate the energy released when these bonds form. You know, the enthalpy change is bonds broken minus bonds formed, right? So enthalpy change is minus 180 and the energy taken in during bond breaking is 2490, and bond formation, he's saying calculate bond formation in its entirety. To calculate bond formation in its entirety. So this is going to go on the left, it will be positive, and this will go on the right, it'll also become positive. So bond energy given out during bond formation is 2490 plus 180. That's what do you get here? 2670. Yes, sorry, my bad. So he's asking you to calculate the energy given out during bond formation, which is this. That's the energy, the overall. He's talking about the overall energy given out. फिर नीचे वो ये कहता है कि calculate करो the CCl bond. नीचे वो कहता है calculate the CCl bond, right? Initially, he just wants the sum of these two, which is 2670. Hope you guys understood this. That's why we need to read the question carefully. All good? See, in this case, we weren't supposed to do this here. We were supposed to do this here. We were supposed to do this right here. What we were supposed to do is, we're just supposed to calculate the total. And, my bad. So why is this not erasing? And the total is literally right here. So he's given you the enthalpy change. He's given you the enthalpy change. He's giving you the energy taken in during bond breaking, and he wants you to calculate this total bond formation. See, the energy released when these bonds form. The entire energy released, bond formation ki baat. He's not talking about the CCl bond here. He's talking about the CCl bond right here. So remember this, yeah? So that's 2670. My bad. Done, sir. आगे जाएं कि बस थक गए? आगे जाएं. My bad. Read the question carefully. Yes, I'll try to do this. So in 2, we calculate without the CCA. No, in 2, what you need to do is, he's saying calculate the energy released when bond formation takes place, right? So he's saying enthalpy change is bonds broken minus bonds formed, right? He's saying calculate this in totality. ये पूरा मुझे बताओ. Don't tell me the CCl bond. Just tell me. Don't tell me the CCl bond. Just tell me the overall energy given out. So remember, see, enthalpy change is minus 180 and bonds broken is 2490. So overall, what is the energy given out during bond formation? So you could use the equation to calculate that the overall energy given out is 2670. Then in the next step, he's asking you to calculate the CCl bond. So what we did was we mixed it up. We did the next step in the first step right here. So here he just wants the overall energy given out. That's 2670, right? And then here, what you need to do is you need to break it down, right, into these steps. So you could say, hey, this was all the energy. We didn't know this, but we knew the total for this. So enthalpy change is this much, bonds broken is this much, minus bonds formation. So we know the totality of this, but we don't know the CCl bond. And then we calculated the CCl bond. Yeah? Make sense now? My bad. Acha, आगे जाएं. Acha. Ammonia is formed by the reduction of nitrogen monoxide with hydrogen. The reaction is exothermic. If it's exothermic, what do you mean? Exothermic means what? Energy taken in during bond breaking is less than the energy given out during bond formation. That's exothermic. And it says complete and label the energy, include the reactants. These are my reactants. these are my products. He's not specified to write the name for it, so I just wrote reactants product. That's the EA. Sir, अभी भी आप question पूरा नहीं पढ़ रहे. I'm sorry. I'm just, going over it and solving as much as possible. So I don't read the question a lot because I've already solved these questions so many times. That's why we end up making a teeny mistake. Yeah, it's fine. Happens to the best of us. अच्छा खत्म. The enthalpy change जो एक बच्चा होना चाहिए ऐसे क्लास में. मूसा, आई एम ग्लैड यू आर हियर टुडे. एक बच्चा होना चाहिए कि देखी चीजों को कि सर सवाल तो नहीं पढ़ रहे, मैं तो पढ़ लूं सवाल. या अच्छा खत्म. कितने मार्क का था? 2 मार्क का. दैट्स इट लिटरली. Again, the same BS here as well. Do you know what BS means? Does anybody know what BS means? It's an overall endothermic or exothermic. Okay, this is an overall endothermic right here. Sir, सवाल तो पढ़ लिया करें यार. Sorry. That's overall endothermic, yeah? So energy taken in during bond breaking should be more than the energy given out during bond formation. Done. Reactants, products. Yes. I'm not writing the formula because he hasn't specified it. If he hasn't specified it, it's better to write the name reactants and products. In the recent papers, he has specified it. So when we were doing the part 1 practice session for this, he said it, write the formula of reactants. So you need to be very careful about what he says. If you look at if you had attended the first practice session for chemical, is there any chapter for which we did not conduct practice? I think we haven't conducted practice session for electrolysis, if I'm not wrong. चलो वो metals के बात कर लेंगे. Metals के साथ थोड़ा connected है. That's the EA and the enthalpy change from the reactants to the products. Done. खत्म. आगे बढ़ूं. कुछ missing तो नहीं है? नहीं. अच्छा, again. Bromine monochloride is made by the reaction between blah, 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 blah. Calculate the overall, use the following step. Calculate the total amount of energy required to break the bonds. Again, Br bond, this bond is gonna break, sir. Cl bond is gonna break, this bond breaks, this bond breaks. So 1 times Br bond breaks plus 1 times Cl bond breaks. Right? So Br bond, that's 190. That's 1 times Cl bond. That's 242. What do we get, peeps? What do we get? 432? Short. 432 kilojoules. Acha ji. Calculate the total amount of energy released when 2 moles. He's even telling you 2 moles of BRCl. So BRCl ke 2 moles. Let's do this. Let's do this shit. Guys, has your chemistry improved or no? BRCl, that's 218. थोड़ी improvement आ गई कि नहीं? That's why I say it's not about PhDs. It's about redox. कब करेंगे? Redox के तो कर नहीं लिए थे हमने. Did we not? Have we not done redox? The entire 100 papers solution for redox has been uploaded onto the portal, man. वो तो कब से portal पे पड़ा हुआ है? वो तो मैंने बहुत पुराने ज़माने में कर लिया था. That's 436 kilojoules. Yeah. What's the overall enthalpy change? Energy taken in during bond breaking minus energy given out during bond formation. यार एक सवाल इसमें which I'm hoping comes up because that's the only type of questions that we haven't done. So that's -4 kilojoule per mole. I'm just hoping it comes up. Explain using ideas about bond breaking and bond making why this reaction is endothermic, why this reaction is exothermic. Hanji. Bond breaking is endo. Remember this? Bond breaking is endothermic. You can literally answer like this in points. Bond like this. Bond formation. Please, it's better to answer like this. See, bond formation. खुला खुला लिख रहा हूं. और bond forming या bond formation is exothermic. And why is this overall reaction exothermic? Because energy taken in during bond breaking is energy taken in or absorbed during bond breaking is less or more. Is less or more. She's saying exo है तो bond breaking में energy कम हुई होगी, bond formation में ज्यादा हुई होगी. So bond, don't forget, don't write it with an absent mind. So you have to be very focused here. Energy taken in during bond breaking is less than the energy. That's why he's given you 3 lines for it. Given out during bond formation. खत्म. I'm hoping that one question comes up, यार. अभी तक नहीं आ रहा. I'm just hoping it comes up. See, it hasn't been tested in so many years. God damn. It hasn't been tested in so long. Look at this. And I reckon that question will be tested in your exam. 100%. If chemical reaction, this is it. This is it. It's this type of question. So I think we'll have to wait for practice session 3 to do this question. You guys want me to continue or is this enough? मजा आया आज? तो अब बाकी आप सारा खुद कर लें. बाकी अब सर अच्छा, I will be doing all these questions with you. Don't worry. In Ramzan sessions, we'll be doing all these questions, including the yearly past paper sessions if you sign up for that. I'll just tell you, I'll just give you, if you guys want to do this on your own, I'll give you a thought process. देखिए, the energy needed to break the bonds, you break all the bonds and write it here. The energy released when these bonds form, you write all the, you take into account all the bonds here, and then you say, hey, this much energy is released when all bonds form, right? Just make sure you don't make a mistake here. You have one OH bond here and one OH bond, so you have two OH bonds and you have 6 moles of this, so 6 times 2, you have 12 OH bonds, right? Don't make a mistake here. And why is this question so special? Because once you do this, you're going to get an enthalpy change. Let's suppose you get enthalpy change of, let's suppose, I'm just giving you an example because I can't skip the order, right? So I'll have to follow the order, but let me just give you a quick recap. What if the enthalpy change is, let's suppose it's minus 1900 kilojoule, right? It's minus 1900, right? That's the enthalpy change. But remember, it's saying write the enthalpy change for 1 mole of NH3. Do you know what this enthalpy change is? This is for 4 moles of NH3. So it's kilojoule per 4 moles. It's not per mole, it's per 4 moles, right? So he wants it for 1 mole. That's why minus 1900 divided by 4, you have to write it for 1 mole. So remember this, but don't worry, I'll solve this on my own as well. I'm just doing it in advance because this is the only type of question that is left. Other than this, there's nothing left in this chapter past paper. You will see all the questions, they're repeat. All the questions are repeat. There's nothing new. There's literally nothing new. Okay? So if you guys want, you can solve this on your own and check it with the marking scheme by asking for the marking scheme from Miss Noor, or you could just solve these questions on your own. Sir, आप MCQs की practice session क्यों नहीं करवाते? I'll tell you the reasoning for it. Once we are done with this, the MCQs practice is already uploaded onto portals. So all the MCQs are already uploaded onto portals, but I want to do like a full gigantic MCQs, like 400, 300 MCQs all together once we do like the yearly sessions. So MCQs, because they're connected with all the chapters, that's why I'm not focusing much on it, but it's all the MCQ practice is also uploaded on the portal. So MCQ सारे portal पे recorded पड़े हुए almost. So you guys can refer to that for more content. Any questions whatsoever? So we'll continue from 2020. Tomorrow we'll have a class. Saturday we'll have a class. 1 p.m. ठीक है कि नहीं? 8 p.m. कर दे. 1 p.m. 8 p.m. Please show up on Saturday's class. We'll start off with acid, bases and salts. अच्छा, Saturday 8 p.m. Sounds good? यार सैटरडे 8 p.m. कर लेते हम, क्या करें, सारे 8 p.m. करें. Saturday and Sunday 8 p.m. Saturday, Sunday 8 p.m. ठीक है? I'll announce it in the group chat as well, because I need to cover up the entire course content, because after acid, bases and salts, I'll switch to organic chemistry. And then I'll see if there's enough time. I think there'll be enough time. Then we'll decide ki kya karna hai. But I want to cover all the chapters live this time. I've just given you 2 recordings of reversible reactions, the industrial process, but I don't want to give you recordings of environmental chemistry or metals or periodic table, because I want to do that in live in the class, because there's a lot of new things that I want to add to it. There's a lot of new things and a lot of new past paper correlation that I want to add to it. So that's why I want you guys to attend the weekend classes so that we can quickly wrap up the course and get things done with. So Saturday, Sunday, 8 p.m. Pakistani time. See you guys. Bye bye. Ciao ciao. Allah Hafiz. Bye. 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 I look so cool. I swear to God. Bye.